Now in this particular section we will see the magnetic properties. Magnetic properties, right? So in case of magnetic property, how the magnetic property works? Actually, suppose we take nitrogen, we are taking nitrogen, right? Nitrogen contains 5 electrons in its outermost shell. So in case of 5 electron containing compound, suppose these two has formed a bond, these three electrons have formed a bond with hydrogen, but there is one extra pair of electron. This one will play a role as a lone pair, and this lone pair alone is responsible for the magnetic property. Now let's see how the magnetic property works. Now let's see how the magnetic property comes. First, an electron, suppose this is nucleus. An electron following its orbit will turn from this position, will rotate in this direction. This will give a magnetic property. This will give a magnetic property, and this particular electron also has a rotational property in this section. This will lead to the magnetic property also. This direction of the spin results in positive direction, and this direction, that is the negative direction. That may be either the counterclockwise movement or the clockwise movement, right? Now suppose we are considering a particular structure, particular metal, which consists of free electrons, right? Which have a lone pair of electrons. In this case, there are certain type of properties, like diamagnetic property. What is the diamagnetic property? Suppose we have a lone pair Fe26. Let's find its configuration, that is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d. Now 1, 2, 3, 6. Right. In this section, 3d section, what we can get? We can have 5 orbitals, right? There are 5 orbitals, and in these 5 orbitals, 1, 2, 3, 4, 5, and then number 6 is there. Now if we consider Fe26, then these will jump from here to here, jump from here to here. But when they are in single condition, they will form certain amount of magnetism. Now what would happen in this case? Then it will be this one, and now this one will be posted in here. It will form a 3d6 configuration. So what is diamagnetic? In here, if we take this particular orbital, what would happen? That this positive rotation of electron and negative rotation of electron, one is in this direction and another one is in this direction. So these two will neutralize the effect of magnetism. So there is magnetic property in each case, right? Now if I am having suppose I am having Fe3 plus ion, right? Then it will be Fe23. What would happen if we consider 4 as 2? Then afterwards 3D3 will be there, right? But in such no case takes place in here. What happens in this case, that is 4s0 and 3d9. So in case of 3d9, as the outermost shell leaves the electron, right? In case of 3d9, 1 2 1 2 1 2 1 2 1. So this single electron, all of these electrons will be diamagnetic in property, but this single electron will show a positive rotation. In this case, this will be paramagnetic, as it do not have any other opposite direction of electron that results in a magnetic neutralization of magnetic properties, such as now here is dia, here is para. In case of diamagnetic, we will have two electrons spinning in opposite direction, but in paramagnetic either two electrons, either a single electron is in this direction or in this direction, or there may be two electrons in this direction. That will also be known as ferromagnetic property. I am coming into that one. But diamagnetic results in this one, and paramagnetic results in this structure, right? So here in this particular case we can have diagram of ferromagnetism, paramagnetism and antiferromagnetism. So let's see what are these things. So in these cases, in case of ferromagnetism, we can see that all the electrons are spinning in a particular direction. They do not have equal and opposite direction like diamagnetism. Example will be chromium dioxide, and then in case of MnO we can see antiferromagnetism. If one is in this direction, another one will be in this direction. Then so upward arrows, up there are 3 arrows, and downward there are 2 arrows. So they are not balancing each other. That's why they will generate a paramagnetic property in heat. And in case of ferrimagnetism, maybe all the directions, maybe all the arrows are in the same direction, all the electrons shows the same kind of spin, but a single arrow will do it in the opposite direction.